Welcome back. Today we're going to start section 2.5, which is called using linear models. So within this section, we're going to learn how to write linear equations that model real-world data, and then how to use those models that we're making to create predictions from the linear model. So the big idea here is making scatter plots. And I know you've seen scatter plots back in probability and statistics, but it's a nice review from those couple years ago when you saw them the first time. So review, a scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. Then the correlation is the strength of that relationship between the data sets. The closer the points fall along a line, the stronger the correlation between the two variables. So if you recall, we label it in two ways. We label it with a direction. Direction meaning negative or positive. And then with the strength. So is it strong, weak, or no correlation? So when you're labeling these in terms of the correlation, I'm looking for those two things. The direction of the correlation, so positive or negative, which again just follows the slope of the line that you're making. And then the strength of it. Is it positive, weak, or is there quite literally no correlation there? So for our first example, the table lists the average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? All right, so what I've done here is I've already plotted it, so you don't have to sit here and just watch me plot the points. So what I'd like you to do is pause the video for a moment and have you plot each of those points. Now, as you can see from the way it's set up, they're using average temperature as X, the electricity bill as Y. So in your table, all of these are X values, all of those are Y values as you're plotting it. So for example here, you'd go over to 61 on the X-axis, up to 150 on the Y-axis, and that is going to give you this point right there. All right. So again, take a moment, pause the video, and make sure you get all of those points down. Now, once you have all of those points, you can make predictions and talk about the correlation. So here, if I had to take a good guess, I would say that would be about my trend line, modeling what's happening with my data. So you can see that there's a positive slope to it, so it's going to be positive. And I think that's a pretty strong relationship. So positive, strong correlation. All right. Now, if I'm just looking at a graph, okay, if I'm just looking graphically and I want to make a prediction, say, I wonder what the electricity would be for an average temp of 70 degrees Fahrenheit. So if all you have is the graph, you don't want to find the equation of the line, all that stuff, all you really have to do is start at that 70, work your way up, and you would say, my electricity will probably be around $170. All right, so that's all you have to do graphically is just kind of eye out that trend line to see, about what is that relationship. And then if you're making a prediction for 70, well, go to that 70, go up to see where the line is at that 70. So that's the basics of what we're going to be doing. Plotting data, discussing the correlation, and making predictions. So a trend line. So I already kind of drew the trend line. That's what I just did on the last slide. But I'll talk about what the trend line really is. It's a line that approximates the relationship between the variables or data sets of a scatter plot. This line can be used to make predictions from the data. So essentially, I made one for you just before giving you the definition for it. That's what I just made on the other slide. Now, let's move on to another example. The table below shows the median home prices in Florida. What is the equation of the trend line that models a relationship between time and home prices? Use this equation to predict the median home price in 2020. All right. So the first thing when you make your scatter plot, which they've already done for us, you'd want to see which is the independent variable and which is the dependent variable. Well, again, independent variable would be your x, so independent would be your years. Your y, your dependent variable, would be the median house prices. All right, which again, you can see modeled right here, x and y. Now, notice what they've done now is they've done number of years since 1940. So basically this would be year 0, year 10, year 20, year 30, 40, 50, 60. So sometimes when you're dealing with years, instead of inputting the whole year, which will get you really big numbers, sometimes instead they'll track years since a certain amount of time, okay? A certain year. All right. So then after you plot all the points on the scatter plot, you would sketch your trend line, which I did on the previous slide, and they've already done here for you. And now, if you want the equation of that trend line, what you want to do is you want to choose 2 points that are actually on that trend line. So I could choose this point here. Okay, that point is basically on the trend line. And there's not another one that's exactly on it, but that one's pretty close. All right, so you want to choose 2 points that are either on or extremely close to the line that you just drew. And so now we have 2 points. We have the point 0, and then 23,100, and the point 40, 89,300. All right. And now that we have 2 points, now making the equation of the trend line should be almost nothing for us because we already did that back in section 4. So given 2 points, we need to find the slope of those 2 points. So subtract the y's, then subtract the x's in the same way. So 89,300 minus 2,300 or 23,100 gives us 66,200 divided by 40. So we have a slope of 1,655. All right, now I am going to erase all that because I'm going to need the space. So 1,655 is our slope. And now we want to write an equation in that point slope form. So remember, that's the generic form of that equation. So let's start plugging stuff in. I already have my slope, and I need to choose a point. I'm going to choose the one with 0 because zeros tend to be a little bit easier to work with. So y minus the y value from the point equals the slope, x minus the x value from the point. So remember, that is a point slope equation. However, if we're making predictions, we want a slope-intercept equation. All right? So slope-intercept equation means we need to solve it for y. We need to get the y by itself. Well, the neat thing is that x minus 0, that just simplifies really nicely to x. So all I have to do is add over that 23,100, and I already have my slope intercept equation. So again, one big idea for this chapter is being able to work between those forms. If you're given 2 points, you need to be able to write me the equation in point slope form and then predict from there. All right, so now we want to use the equation to predict the median home price in 2020. All right, so the first thing is, what would our X be in 2020? Because remember, it's years since 1940. So that's going to give us an X of 80. 80 years would have passed from that 1940. And now that we have our equation, now that we have that, now we can just plug that in to make our prediction. So type that into the calculator, and you're going to get $155,500. That's what the median home price would be expected to be in 2020. So again, the big idea, make the equation, and then plug in the value to the equation to make the prediction. So let's do this one more time, just make sure we've got it. So this table shows the number of hours a student spent online the day before a test and the test scores. Make your scatter plot to describe a correlation and make the trend line. All right, so in this one, again, I've already plotted for you, so you don't have to sit here and watch me plot it myself. So hours online, we're saying is the independent variable is our X, and we want to use it to predict test scores, so the Y values. So just again, this point right here, 0, 100 would be that point right there. So take a moment, pause the video please, and once you're finished, restart it so you can keep watching after you've plotted all those points. So again, once you have all the points, the next step is drawing our trend line. So I'm going to say my trend line looks just like that, okay? And again, not the straightest of lines, but it'll do. Okay, you're looking to get about half the data above, half the data below your line. So first thing to describe it, well this time you can see it's a downward slope. So it's going to be a negative correlation. And I'd say it's still relatively strong. So we're going to say that this data has a negative strong correlation. Now, I actually want to find the trend line of the equation. So I'm going to take this point here, which is actually the one I already used as an example, and then this point right here also falls on it. So that's going to be the data point 4.5. So I'm going to use those as my 2 points, and I'm actually going to make the equation of this line now. So to make the equation of the line, remember, I'm going to have to find the slope. So 100 minus 57 over 0 minus 4.5. So that is going to give me 43 over negative, over negative 4.5. All right, so when you're dealing with these trend lines, remember I said I don't like working with fractions? Well, I will make an exception here because these trend lines aren't exact anyway. So it doesn't really matter if you give me the exact value or not. So I'm not going to require you to use fractions here because I'm not expecting perfection. This is based on the points you choose, and there's no one right answer. So I will let you just use a fraction for this, or a rounded decimal, I mean. So you would get about negative 9.556. And again, if you use two different points, you get a slightly different answer. However, just in general, they should be about the same as you go through this process. So that's going to be my slope. I have my point, and again, working with ones that have zeros are typically easiest. So y minus the y value from the point equals our slope, x minus the x value from the point. So again, that is a point slope equation. But with trend lines, since we want to be able to make predictions with these, we don't want to leave it in point slope form. So again, since that's 0 there, the x minus 0 just becomes x. And so all I have to do is actually add that 100 over. And then here's my trend line in slope, intercept form. And as always, if you want to be making predictions using this, we can do that. So let's say we want to predict how a student would do who spent 6 hours online. So again, all you'd want to do is plug in that 6 and then plug it into the calculator. So we would expect about 42.7% on that test if they spent 6 hours online. All right, thank you so much for joining me for this one. And as always, a lot of good stuff, and especially because this deals with a lot of real-world examples, I feel like you can give me a really, really good summary of it. So take a moment now, review what we just discussed, write me that summary, and then come back to class prepared to do your practice work.